In this video, we're going to take a look at how we find the area between two curves. Now, we already are familiar with area and area under a curve with definite integrals. We're already familiar with that. But what that does is finds the area from the function all the way down to the x-axis. And so what we're doing here is a little different. Here I only want the area that's trapped between one curve and another. All right, so how are we going to do this? Well, somebody had a very smart idea to compute this guy's area. The first thing we're going to do is look at what we would have if we integrated from a to b of just f of x, right? Just f of x. Would that numerical answer, would this area be too much area or too little area? Well, hopefully you would say that this area here would be too much. And matter of fact, I can even probably sketch it for you on our picture here. The integral of just f would give us from f all the way down, right, all the way down to the x-axis. So from here all the way down, which will be too much, but it'll be too much precisely by what quantity? Well, it'll be too much by the integral of g of x from a to b. And so if you look here, the yellow x's here would be the area under g. And so really all we want to do is take that original integral of f, which is too much area, and subtract away the integral from a to b of g of x dx. And I can even do one better than that. If you notice, these limits of integration are the same, and you're integrating with respect to the same variable. So there's no reason that these two could not be combined just into a single integral. It's kind of like using the sum and difference rule, but going backwards, taking a difference and writing it as a single integral as opposed to breaking it apart. So the area trapped between these two curves would be the integral from a to b of f of x minus g of x dx. And really the only thing you have to keep in mind is if you're not provided a picture, you have to make sure that f is the top curve and g is the bottom curve. And they may not be called f and g, it doesn't matter the letters, but just make sure that your top curve is listed first and your bottom curve is listed second. All right, now there's some other issues we need to talk about just very briefly before we close. A very common problem is if they don't provide you with the limits of integration, but instead they say that there is a region that's bounded by two curves. And so if you look at a graph like this that has one of these bounded regions that we're talking about, you see that there's a certain amount of area that's trapped between f and g. And so we can just kind of decipher where the beginning and the ending points would be, namely right here at A and right here at B. But the problem is that they're not going to provide those to you. So what do you do if they just say, oh, well, there's a bounded region, find the area of the bounded region between this curve and that curve? Well, what we have to do is it's up to us to find the intersection points. So you find the intersection. Now, how do you do that? Well, you simply set f of x equal to g of x. So this might be, a quadratic set equal to a cubic, or one trig function set equal to another trig function, or who knows what type of equation you could get, but you set them equal to each other and you solve it, and the answers that you get will be the places that these two curves intersect, which will in turn turn out to be your limits of integration when the time comes. All right, and the last typical type of wrench that you'll see thrown into these types of problems is, what if there is actually multiple bounded regions? This is very common as well. So if you look at an example like this, you say, oh, well, okay, I see the area or the region that they're looking for here. If we'll call this A, and we'll call this, we'll just call it B, for example, then I'll just do the same thing, the integral from A to B and, whatever. But there's a problem with that if there's multiple bounded regions. Remember how I was talking about top curve minus bottom curve? Well, you look in the first region, F is the top curve and G is the bottom curve. But then after a while they switch, and then G is the top curve and then F is the bottom curve. So there's not one consistent integral that you can actually write down. So what do? Well, we actually break this up into multiple integrals. So let me show you what that's going to look like here. We'll integrate from a up to, let's call this c. We'll call this a. We'll insert c in the middle and then b back here at the end. We'll have the integral from a up to just c of f minus g, and pardon my abbreviation, I'm just trying to keep this short so it doesn't go across the screen too much. But yeah, integral from a to c of f minus g, which is top minus bottom dx, and then to that region or area I'll add the integral from c to b the rest of the way, where I do g minus f dx. All right, so that's how we handle really all the different types of problems you'll see. You won't see too many much different than these. And so anyways, hope that helps you understand how to find the area between two curves. And if you want to find some more of these either example videos where we work some of these out, or some other math videos, visit my website, fireflylectures.com.